Now, the next concept is finding the square root of a complex number. So let's see this example to illustrate how to find the square root of a complex number. The question says, find the square roots of 8 plus 6i. Now, to find the square root of a complex number, that means that number is a squared. For example, if I ask to find the square root of 4, that means 4 is from 2 squared, isn't it? And that was why you could find the square root to be equal to 2. If you ask to find the square root of 9, 9 is 3 squared. That was why you could find the square root of 3. So since you are asked to find the square root of this, so what that implies is 8 plus 6i is a square. I hope you understand that. Is the square of a number. So since this is a complex number, we will say that 8 plus 6i is the square of a complex number, and a complex number can be represented as x plus yi. Okay, since this is a complex number, then the square is 8 plus 6i. I hope this is well understood. I repeat, if I ask to find the square root of 4, that means 4 is the square of a number. That means 4 is 2 squared. If I ask to find the square root of 9, that means 9 is the square of a number. That was how you could find the square root. So for you to find the square root of 8 plus 6i, that means 8 plus 6i is the square of a complex number. The complex number I don't know. So that implies that it is equal to x plus yi squared. So that means x plus yi must be the square root of 8 plus 6i. So since this is understood, then I can now expand this bracket. That becomes 8 plus 6i is equal to x plus yi and x plus yi. Okay? So 8 plus 6i becomes x squared. Then this becomes plus xyi plus another xyi plus yi squared, y squared I squared. So that means 8 plus 6i is equal to x squared. This becomes 2xyi. The I squared is -1 minus y squared. Okay, so if I group it in terms of real and complex number, this an imaginary number, this becomes x squared minus y squared, which is the real part, plus 2xyi, which is the imaginary part. Then what I'm going to do from this point is to compare coefficients. So this is real, this is real. That implies that x squared minus y squared is equal to 8. This is imaginary, this is imaginary. That implies that 2xy is equal to 6. I hope this is well understood. So this leads to simultaneous equation. So this is equation 1, this is equation 2. So let me solve equation 2 first. It's kind of very easy. So 2xy is equal to 6. That implies that x is equal to 6 divided by y. So x is equal to 6 divided by 2y, isn't it? So that means x is equal to 3 divided by y. Since the value of x is 3 divided by y, then that is equation 3. Then I can substitute the value of x into equation 1. So that means from equation 1, x squared minus y squared is equal to 8. So x becomes 3 over y squared minus y squared is equal to 8. Okay? So at this point, I can have this as 3 squared, that is 9 over y squared minus y squared is equal to 8. So, of course, you can multiply all through by y squared, right? So that becomes 9. If you multiply all through by y squared, so that this way can cancel this y squared, this becomes 9 minus y raised power 4 is equal to 8y squared. Okay, when you multiply all through by y squared, so at end of the day, when you take everything to the right hand side, it becomes y raised to power 4, okay, plus 8y squared minus 9 is equal to 0. So don't panic when you get to this point of y raised to power 4. It is easy to solve with quadratic equations, isn't it? So you can split this down to quadratic equation. You can write that let a equals to y squared. Okay, that will be very easy for you to solve. You can write let a be equal to y squared. But you know that, don't forget, when you are solving in terms of a, but the value of a is equal to y squared. So that this can be expressed as y raised to power 4 is now a squared, right? Plus 8a, because a is y squared, minus 9 is equal to 0. Then you can easily solve this as a quadratic equation. So the factors of minus 9 is 9 and is 9 and minus 1, and that gives to 8, and that gives 8. This becomes a squared minus a plus 9a minus 9 is equal to 0, because minus a plus 9a is 8a. So at this point, your normal factorization method, which becomes a minus 1, then plus 9, a minus 1, isn't it, is equal to 0. This becomes a plus 9. You have to be careful with the way you write your a and 9. So I also have to be careful. A plus 9 and a minus 1 is equal to 0. So what does this mean? That means the value of a is equal to minus 9, or the value of a is equal to 1. All this is understood. Then you now remember that we said earlier that let the value of y squared equals to a. So this implies that y squared is equal to minus 9, isn't it? Or y squared is equal to 1. So at this point, this value has no real roots, right? Don't forget quadratic equation, no real roots. Because you cannot find the square root of what? The square root of minus 9. So that means only this has real roots. That means the value of y squared is equal to plus or minus square root of 1. That means, sorry, y is equal to plus or minus square root of 1. That means the value of y is equal to plus or minus 1. I hope you understand that. So you are asked to find the value of x and y. Recall that the value of x is equal to 3 over y. The value of x is equal to 3 over y. So since the value of y is equal to 1 or minus 1, that means the value of x will be equal to 3 divided by 1 is 3, or 3 divided by 1 is 1 is what? Is minus 3. So that means y is equal to plus or minus 1, x is equal to plus or minus 3. Do you guys understand that? But just write this. So y is equal to 1, x is equal to 3, or y is equal to minus 1, x is equal to minus 3. I hope you understand this. So getting the value of x and y does not solve the problem. You still have to write the square root, okay? Don't forget, I told you earlier that the square root is x plus yi. So that implies that the square root of 8 plus 6i is equal to, don't forget, x plus yi, isn't it? So the value for x is 3 plus I, because y is 1, or 3 minus I. That is, when x is 3, y is I. When x is minus 3, y is minus I. I hope this is well understood. Thank you. See you in the next.